My name is Chyuan. Our company is JETK Innovative Tech. So actually, I will be talking about this topic, producing animated short in Unity. Can you guys hear me from the back? Cool, awesome. Okay, so a little bit of our company first, shameless plug. So ours is a tech company with affordable solutions that value artistic content as well as technical innovations. So our services, if you see in our showcase, we include 3D walkthroughs, VR, AR content, and web solutions. And also, during our free time, we try to be a little bit more creative, as we're actually from the animation and VFX industry as well. You can check out our company, jetk.com.my. We are a Malaysian company, so feel free to drop us a call. So why do we use Unity? Because the pipeline is generic and it fits into any production house. If you can see the picture on the right side, I'm pretty sure like most of you know where this is going and then where it's supposed to end. There's actually a hidden piece here that we didn't feel it would be appropriate to include. But basically, yeah. So it comes in with idea, then there's storyboarding, animatics, design, and then we come, that's in pre-production, and then production, where you do all the setups, and then post-processing, and then, the standard client interaction. However, Unity is sort of pipeline where instead of the linear pipeline where you have to go through all the layers and departments, which actually comes from mostly from the film background, we actually can move everything in parallel. So let's say, for example, a modeler has some artistic changes. They actually can still go back into production because everything is moving really, really fast. Concept design can be refined throughout, and you can move everything seamlessly. And here, this is also a game production pipeline. The concept, modeling, sculpt with topology, UV mapping, especially for game developers. If you're not sure what these are, these are the production workflows, especially for game development: baking, texturing, rigging, grooming, animating, posing, lighting, shading, compositing, and final image. All this can be done simultaneously in a way with the help of these real-time production workflows. So the pipeline is similar to traditional workflows and easy to integrate into existing pipelines. Fast rendering and allows for faster iterations. And also, this is a cool thing. It's a client-friendly pre-visualization. Because as 3D artists, sometimes you'll be reluctant. It's like, oh no, I have to render like a bunch of stuff again, and I only have like half a night. But in real-time production, it is pretty much super fast. It's cheaper. As this was a test project, we did not allocate a render farm budget. So you can see our little test project. We only allocated like 500 Malaysian ringgit, not even Sing dollars, to actually create it. If you actually work in a render farm, let's just say you can project it. 2-minute short film could cost you about 7 to 10,000 Malaysian ringgit, which is not cheap. Whereas we only spent like 500 ringgit to get everything completed. There's also a vast resource from custom tools and shaders. So especially if you go to the Unity Asset Store, there's a whole lot of stuff for you to study and a whole lot of stuff for you to push into your pipeline. If you have something in mind, you can either build it or people has built it for you. Just be sure you spend and support the technologies. So introducing Purebred, our little pet project we did during our free time. Okay. Yeah, so that's about it. You can actually achieve this quality in Unity. And I'll probably show you some stuff that we did that helps you to accomplish it. Where's my presentation slide? Okay. So that is Purebred, our baby project. And we'll be trying to do more of these throughout the year as well, 2019. So what it is a small in-house test we did to manage a real-time rendering solution. We worked on it during off hours, 2 to 4 people. Most of the time, it was just about 3 of us, mostly working on it. And on a budget of 500 ringgit for permission to use the IP. So as you can see, like rendering, working in manual labor, everything was we did it ourselves during our free time. You can actually check out this art station. Her stuff is the IP that inspired us to work on this project. This little Shiba Inu. The concept was to blend both Japanese and European influences to achieve a stylized look that would translate well enough, not only as a shot, but also as augmented reality. We also work on augmented reality solutions as well, and we have a couple of animation projects that we develop for augmented reality. You can see later why we actually limited our space, because we tried to do it as an augmented reality solution as well. So these are our concept pieces. Some influences are here's the plan, feast, fox and mouse, just to study like the proportions of the Shiba Inu, and then how we can stylize it to keep it readable. Because when it comes to stylization and also for like augmented reality solutions, it's best to keep everything, keep not too much detail into the scene. If you put more detail into the scene, it becomes very noisy. And especially for augmented reality solutions, you want to get everything clear to the audience. So as you can see, this one here has clear blocky shapes. There's nice contrast, and then this is our inspiration. So the environment was planned as a diorama to work well in AR. So especially if you are planning to move stuff into AR as well, try to plan stuff that will actually fit into your scene. You can actually expand it if you want to, but because this was our small pet project, we just wanted to keep it simple, as we also deal with architecture, and it looks somewhat close to this, and we wanted to keep the same theme as well. The style was inspired by films such as Sonder, which actually published just like 2 days ago, and they're actually winning a whole lot of awards, and it was actually made directly in Unity. You should check it out, and the making of is actually on the Unite page itself. And here's the plan. This is not done in Unity, but also was quite a huge inspiration for us. It's a sorry. It's a hand-painted, cel-shaded look with bold shapes and colors. So this is where this is what inspired us to work on this stylized film. Bold shape and colors. Truly, just check out Sonder. It's an amazing job. Done by a whole bunch of international artists. Okay, so we decided to work on Unity 2017.2 as we found out the conversion to Unity 2018 was not really a problem using the standard workflow. Because we actually had experience working in 2017 for AR, we decided that we actually tested out earlier on that 2017 we tried to convert the file. It worked seamlessly. So especially if you're working on a standard workflow and not the HDR-based solutions, everything translates well. And then finally, also we currently have like AR projects in 2018 as well. Everything is fine. All our scripts works well. As we wanted to convert our scene later in AR, as we kept assets optimized for minimum draw call. So especially for AR solutions, keep everything to a minimum. Do not overbloat your scene. So you can see our topology here. It's pretty clean, and our maps try to keep as least maps as you can because it is safer for batching. And these are the few maps we just use. Actually, if you want to, you also can just get away with this map and this map for AR solutions, and also our stylized film itself. We could just get away with this because we were going for a more stylized look. And for AR, you do not want to bloat yourself with too many maps to make your scene a lot heavier. This is a little hidden feature in Unity. It's a built-in look depth tool which allows for quick prototyping with neutral HDRI. I can just show you quickly where it is situated. Where is it? Experimental. Oops. Sorry, it's about. Let me take it out. Experiment. Here. Okay. Yeah, so basically it's a pretty simple scene where you can put in your assets. Sorry, my computer is a bit laggy. Yeah. Basically, you can see the reflection ball here, and you can see the gray ball. If you come from the VFX industry, basically this one is just to check out your reflection map, and this one is where your direction and your intensity of your light is coming from. You control your EVs here, and you can also plug in your own HDRI for, let's just say, for example, heavy. All right. Let me just. Yeah. Yeah, so you can actually play around with the HDRIs that you'll probably be using in your scene throughout. Environment, you can also switch from one environment to the next. Right now, it's actually reading from this environment. When you push it to one, you read into the next environment, and can play around with all these to check the performance of your model and see whether, just quickly prototyping. If you actually want to go for a more standard workflow, I would suggest also you try to use a studio rig. The 3-point lighting or something diffuse, where you actually can, sort of gauge how your assets will look like in the neutral lighting. Okay. As for shaders, we decided to go for a more stylized look towards cell shading instead of the built-in PBR. Like I said, because we wanted to move into AR, it makes sense to target something that is mobile ready. So this one here is one of the tools that is actually pretty. What happened? One of the tools that's pretty popular. Actually, the author of it, Jean Moreno, he's the guy who worked on Sonder itself. He actually developed this shader. You can go for a cell shading look, as you can see here, which is a more hard edge one, or you can actually diffuse it a little bit to get it to be a bit more. The color in the screen, I think, is a bit off, but it looks a lot better on my computer. Yeah, so just play around with it, 0.01, you can get it to be a very more hard edge. And then the ramp smoothing, let's say I change it to 0.1, it becomes a little bit more softer and diffused. I mean, sometimes this is just all you need to get good looking stuff. The normal map is actually kind of, if you want to, you just put it in, just readjust your color and highlights, because sometimes, especially for texture artists, especially when you're in a rush, you do not want to go back into the texture to readjust, but you can actually tone down your texture maps via this, which is actually pretty useful. And then if you see Sonder itself, they kind of tinted the shadow color, so you can get maybe, let's say, a bluish shadow instead of a pale black one or a darker black one. Okay. Maybe let me just show you a bit of the shader. Okay, as you can see here, it's mobile. So actually it works in even mobile phones and lightweight solutions. I think you probably also can get away with it in VR. If anyone tries it out, just let me know. Then yes. Cool. Let's see. You also can readjust your shader tools. You have unpacked shaders here. This one will take some time, but if you want to create your own shaders, just go ahead and mess around with this stuff here. You can select, let's say, for example, rim outline. These are pretty cool. Sometimes when you want to fake in your rim lighting, you can readjust that. If you want to keep it even streamlined, you can create your own ones. Just select the properties that they have here. Let me just show you a little bit of the rim lighting. I guess it's pretty interesting. Yeah, so you can sort of fake out a grim lighting pretty easily. Yeah, you need to mess around with it a little bit more, but you can actually fake a grim lighting with just the shader. In fact, even in like DCC solutions like Maya and Max, you probably it's best to trick the shader to give you your rim lighting instead of trying to get it directly created in real life lighting, especially for for stylized material. Okay. So about the lighting, we use real-time lighting as it reacted better with the shader. Yeah, that is one of the problems with the shader. Not really a problem, but let's just say, one of the problems of the shader. It doesn't work so well with backlighting. You need to work with real-time lighting for it, which in our case, because we had everything kind of dynamic in a way, it's okay for us. And it's also because we for this version, we wanted to just do a short, for this thing you're seeing now, it's mostly for a short film, so we could get away with real-time lighting. As you can see here, it's necessary for non-static objects as well, such as the dog. Later on, you can see the cloth, which is done in alembic, and yeah. You can try also SeeAnyLight, which is pretty useful. So SeeAnyLight, you can download it from the GitHub, which I can show you a little bit about it. SeeAnyLight. As you can see, it's actually attached to this character. Okay, global controller, spine, SeeAnyLight. So actually, if I turn it off, oh yeah. So you can actually set up your 3-point lighting, parent it to your character, and then you can mess around with as many properties as you want here. So it actually works exactly like a spotlight. So it does help a little bit, especially when you want to adjust it just for your characters. So try give it a go, SeeAnyLight by Laurent. Okay. Also, yeah, we had a few problems, especially for real-time lighting. You might get certain artifacts. So as you can see here, there was a little bit of a problem. If you want to know, we actually baked the real. We baked the real-time lighting, and then we got off real-time lighting. As you can see, would be here. Where's my lighting? Yeah. This is a setting we use for it instead of using big lights. So real-time global illumination. You actually can get away with real-time lighting without baking the global illumination. But if you want to get a more, if you want to get global illumination, just check that on. You can get a pretty better results. The only thing that probably doesn't affect so well is the moving character. But static objects, you get it pretty well. But for dynamic objects, you get a little bit of bounce lighting, which you can readjust inside the light itself. So in my light, yeah, this affects it. Indirect multiplier, it helps to give a little bit of boost in the global illumination. Just turn that one on, just play around to your heart's content. Okay, so let's say when trying to remove these artifacts, in our case, this problems can be solved if you mess around with this here. Generally, you have this set at like the light parameters is at default medium. You can go up to like high or very high resolution. Sorry, not very high, but high resolution. You can see here it's actually blacked out. But if you want to create your own one, just click Create New, and then we readjusted our properties based on that. And then you can see, like, for example, our modeling tolerance. Yes, our modeling tolerance. Yeah, yeah. We dropped it down to 0.01. That helped a lot. It removed actually these artifacts. And back-facing tolerance. Back-facing tolerance, yeah, it's Yeah, we readjusted that to also be about 0.001, and it helped to remove these problems. And also, if you want to check out, like, let's say, what is your problem with your, especially for real-time lighting, since real-time lighting, they don't work in a way where if you've done backlighting, you actually have to readjust your UV tools. But for real-time lighting, they actually give it to you automatically. It's pre-calculated in Unity itself. But you have to readjust your clusters and so on, and make sure it doesn't look something like this. This was one of the problems we had, which actually sort of caused our lighting to not look the way we wanted it to. To visualize your so as to visualize it, just go down to visualization, and you can check around here. In my case, you actually have to bake it first because we didn't rebake it. You cannot see it, but just mess around with clustering, lit clustering, and you can actually see this. In this case here, this one was lit clustering. You'll get this sort of data. As you can see, there's also a little bit of a broken mesh here. That is actually caused from our, our modeling tolerance and back-facing tolerance. So please readjust it to actually get better results. Also, our post-processing. If you've worked on Unity before, make sure you take care of your tone mapping. In our case here, you can go for the other one, ACES, but then we felt that it was a little bit too contrast, so we went with neutral. If you've worked on DaVinci Resolve before, they actually try to get everything to neutral first before they tweak it out with other extra post-processing like curves and color balance. So in our case, we wanted to follow the same pipeline, and we just kept it at neutral. We readjusted our black in, whites, and all this data here. And then we try to get it as neutral as possible and white balance it first before we add our own little readjustments in here. White balance, you can try and get it here in temperature. So let's just say if it's overly too warm, drop it down. And if you want to go for a bit more realistic toning, you can try to readjust your saturation. Yeah. Okay. And then also make sure anti-aliasing, because anti-aliasing is really important when you're trying to get proper looking stuff. When you render stuff from like V-Ray and so on, if you get like anti-aliasing or noise, that will actually break the illusion of a 3D object. So tweak it out here. In our case, there's another one that's called temporal fast anti-aliasing, but I think fast approximate anti-aliasing with extreme performance would be better suited for our case. Also because if you set it this way, we actually can see it in the viewport, whereas if you set like temporal anti-aliasing, the viewport has a little bit of a wonkiness, so we decided to just keep with the fast approximate anti-aliasing. Okay, overall animation was handled by Cinemachine and Timeline. So if you guys have installed this, kudos, Cinemachine. Animation can be exported via game engine export to your DCC of choice. So, I mean, basically that's the pipeline we can work on. I mean, in our case, we predid most of our assets in in Maya, yeah. And then after that, all you need to do is just export it via game exporter. And then if you're talking about like claws and deformation, you might want to export it via Alembic instead. The difference between like FBX versus Alembic is more for deformation, as you can see, like the cloth just now. Yeah. Yep. Also, other functions for Alembic is like for simulations, maybe water simulation, so on, and you can use Alembic instead. Facial simulations, yeah, you can use that for that as well if you want to go for a more extreme. Because FBX might not get the proper results you want. When you export as Alembic, the skeleton rig is no longer imported to Unity, just the deformable mesh. So just take note of that, because if you export via FBX, you can see that there's an animation rig and so on. So don't be afraid if you do not find that in Alembic anymore. So yeah, let's just say, for example, Alembic. Yeah, you see, there is no like stating where is your model, your rig, your animation. Everything is based in here, and then it ports properly into timeline. If you want to use Alembic, you might want to go and type in Alembic importer online, and then you can get the GitHub to download the asset for you to import it in. If you find that you see this folder, UTJ, then you're on the correct direction. I think maybe I have a slide here for its placement. It's a link. Do I? Oh no, I don't have. But anyway, yeah, so just typing Alembic importer, import that in. Once you see like UTJ, then you're pretty much in the correct track to import Alembic stuff. Also, another new thing introduced in 2018.1, so actually it's not really new anymore, it's quite old, is the FBX Exporter. So it's actually for DCC round tripping. So imagine you actually want to gray box stuff inside Unity itself. Maybe just for quick animation, you want to get a car moving from left to right. So instead of doing it in Maya, you want to do your blocking first in maybe Unity, just move your car from left to right, export it out using the FBX Exporter, and then in Maya you can sort of give it to your animator for them to figure out the blocking and then re-import it back into Unity to be used. Or an alternative workflow, so an alternative workflow is basically export FBX from Unity, and then export instead of bringing it back from Maya into Unity, you can actually export as an Alembic again. That way, I mean, if you do that, if you have any problems, you can actually directly just export it from Maya as an Alembic and back into Unity after your DCC application. In your DCC application after you have polished. So FBX Exporter. Okay, so as for camera, the camera is a mixture of both standard camera moves and Cinemachine follow and look at. So what I mean by the standard animation moves is where you keyframe it as per usual. So most of you has used a timeline before. So let's just say, for example, I've dragged in my main camera. I dragged it in here already. Right click, add Cinemachine short clip. Create, and then what you'll do is you'll create a virtual camera, which you can actually use it to port in like your data here. So what I mean by follow and look at, these are the two terms that you might want to, two functions that you might want to control. So follow is basically a translation of your camera. Let's say I set it to follow this dog while he moves around. You just put in, let's say for example, your maybe something that targets your dog. Maybe it's dog head or dog rig of the head. Plug it into follow. Once the dog moves, the camera will follow the dog, and that is where you get your translation of your camera automatically. And for look at, it's more of a panning of the camera. So it stays in nodal position, and then as the dog passes by, it will go from left to right. So let me just show you the look at. It's a bit laggy, but bear with me here. So let me just delete this. Try shot 3. Add Cinemachine shot clip. Okay. So this is the camera I've created. Now I just want to get my camera to follow, let's just say, this tray over here. So right now I just need to position my camera, my starting position. Where's my camera? Okay, so in a bit you'll see that this tray will move from left to right. trolley, and then let's just say I want to sort of get it to look at this cupcake here. Cupcake B. So just pull it here to look at, dump it in. You'll get this composer. You can control it via the aim here. Readjust your spacing. You can do it here, but it's a little bit laggy, so I will just readjust it here instead. Okay. So what this means is, as soon as this cupcake exits this free space here, the camera will start moving. And as for this blue space here, if you leave it to, if you leave enough of these blue spaces, what it does, it will get a little bit more of a smoother camera move. If you have a far bigger space of this clear space, what happens is you get a more mechanical move of your camera. So right now, let me just drag, and you see, okay, as soon as it exits, your camera will start moving. If I zoom out here, you can actually see it a little bit more clearer. Okay, see, my camera will start moving as soon as this touches the border of this blue line. Yeah, okay. As for standard camera moves, what you can do is, like in the case of this shot 1 here, this wasn't treated with Cinemachine. What you just need to do is drag down your camera. Let's say, for example, shot 1, drag it down here, click this button, and just keyframe your camera. So let's say I select shot 1, right click, add key. When you start off, you just need to click add key. In this case, it's update key, and then start moving your camera from your rest position to your position where you want to move your camera. So that is how you animate it normally. Okay, and below is a breakdown of our common use tracks. So as you can see here, there's animation tracks, which I use for my animation of my animated characters, my trolley, my Shiba, my door, and also I actually animated my characters here, animated my camera here with the same technique. And then Cinemachine track is where you place your camera, which has the functions of look at, follow, and so on. Keep it standard here. Activation track, you probably want to use it for like simulations, which will tell you to just activate as soon as it gets into that position. So activation track is here. What it does is actually it will turn on a candle, a little flame somewhere around here. When you click play, it will start to actually showcase that. And then Alembic track was for my cloth here. So all you need to do is just drag it in directly into the timeline, and then ta-da, you can see that my cloth has been pulled down by the dog. And then rendered via track recorder. So a little heads up about track recorder. You just need to download it from the Unity store. Just look for Unity Recorder. And then to record stuff, just right click, recorder track, select it, and you can actually record your entire animation and export it off. And also you can, a pretty cool thing is, let's say for example, you animated your camera in Unity itself, you can select the recorder track, select, okay, yeah. So instead of video, set to animation clips, drag your camera in, and then you can export your camera, let's say from Unity into your DCC application. You also can do that similar like the FBX Exporter. You animate in Unity, export it out, you can use this instead. So not only can it export videos, but you also can export animation. And yeah, so thank you guys.